In this video, we're going to talk about dependent and inconsistent systems. Now, each of the systems of equations that we've considered so far in the videos have had a unique solution. In other words, there's a unique ordered pair, x comma y, that makes the system true. But we're now going to consider systems that have many solutions, really infinitely many solutions. Those are called dependent systems. And other systems that have no solutions at all, and those are called inconsistent systems. Okay, and it's not obvious right from the beginning of looking at a problem whether it has no solutions, one solution, or infinitely many solutions. So let's see what happens if we were to try to solve such a system that doesn't have a unique solution. Okay, now let's look at this system of equations. I want to use the elimination method. Let's multiply the top equation by -4 so that we can get rid of the x's here. We'll have a -8x plus 8x. Those will go away. So what we get is -8x, and then it's really plus 12y, because -4 times -3 is positive 12, is equal to -68. Okay, -4 times 17 is -68. Okay, let's leave the bottom equation the same. And notice what happens is that on the right side we get -58. On the left side, the x's go away, so that's 0, and the y's go away, those. That's also 0. The left side is just equal to 0. So we get 0 equals -58, and that doesn't even make sense. Okay, so what happened? Well, I was trying to eliminate the x's, and it just so happened that the y's also got eliminated. And what we ended up with is an absurd statement. Okay, 0 is equal to -58. So what we say in this case is there is no solution. Okay, there's no solution. In other words, it is inconsistent. Okay, so if you try to use elimination and you get some statement that says 0 equals some number other than 0, okay, like 0 equals -58, your system is inconsistent. Okay. And the other possible scenario, notice I've changed this system just ever so slightly. In the top equation, I had 8x, in the top system, I had 8x minus 12y equals 10. Here I have 8x minus 12y equals 68. Okay, so I changed it just a little bit. So let's see what happens. Well, again, let's multiply the top equation by -4, and we get -8x plus 12y is equal to 68, and the bottom equation would be 8x minus 12, equals -68, and the bottom equation we would get 8x minus 12y equals 68. Now notice what happens when we add both equations up. The left hand side will be 0 and the right hand side will be 0. So that's actually a true statement. 0 equals 0. So what this means is that you have infinitely many solutions. Infinitely many solutions. In fact, what it really means is that when you graph the top equation, you'll get the same graph as when you graph the bottom equation. Okay, so there are infinitely many solutions, and so we say this is a dependent system. Dependent. Okay, one other thing too, in this inconsistent system up here, what does it mean to say there's no solutions graphically? Well, if you were to graph these two lines, they would be parallel lines. Okay, they would not be the same line, but they would be parallel lines. Down here, if you were to graph these two lines, they would be the same line. Okay, so you get infinitely many solutions. Any point on that line would be a solution.